Welcome to the webinar. The project presentation is delivered by Ashwin. It's about project backup repository and avoiding requirements creep. I do web and software development based on compiler-based, interpreter-based, and compiled interpreter-based languages. I'm going to talk about the particular presentation that affects development. There are two concepts shown on the screen. One is the project backup repository, which is the business process part, and the other one is the requirements creep, which is the business function part. A business process, BPM, and business process model and standardized procedure to model system-based interactions. It is a non-standard procedure to model a system using business functions. This is because business functions related to legal framework, and you don't model a system using a legal framework, whereas business processes are data-centric. Ones that use data-centric processes are new generation models. A project backup repository represents a software that records information requirements and produces usable forms out of it. I've shown here a candle representing the project blast off stage within a project backup repository. Whereas creep, I've shown a small circle from where the requirements, inside a pool of requirements, from there, the requirements leak out of the circle into the pool. Requirements creep is seen as one of the major problems in enterprises when developing new software. And that is exactly why we need proper documentation. It is a fact that around 20% of the company data is in metadata and 80% becomes the data that the company processes. This is 80-20 rule. No company can fully use 100% of this data it processes. A project backup repository requires a requirements dataset containing about 1,000 requirement definitions that will give the adversarial learner to resolve requirements into features or feature sets and subject area. So the entire pool of requirements or the cluster of requirements is parsed or is learned by the deep learning algorithm using an adversarial approach in order to resolve the requirements and as well estimate the requirements from its story points. So all of the resolved requirements will be in the templated format. The template is as per provided below. The template for the feature is action, the result by, for, of, or to an object. Feature sets, the template is action or actioning an object. Subject area, the template is object management. By this way, we can hierarchically organize the requirements from subject area to feature sets and then to feature. This is one of the requirements examples. Here there's a data steward who manages data as it writes the requirements in a piece of text. The admin team here requires a dashboard with tiles to manage the bookings that are due. The kiosk as well uses the same interface for the customers to avail that booking or even book a new show. Using the dashboard with tiles interface, searching for booking based on reference number is easy. So these requirements text consisting of 3 sentences is being resolved into 4 requirements, and one has a type of hierarchy and one has the requirement. The type of hierarchy consists of subject area, feature sets, and feature. The type of hierarchy, the first one is subject area, which is dashboard management, as it uses a dashboard. Here, dashboard with tiles to manage bookings. Then feature lists the bookings of the customers Then feature set says searching the bookings. Then feature says search the bookings by the reference number. Here is another example of resolution. It focuses on API request sent and JSON data retrieved. The requirements test goes by this. Revisiting on the issues with API results. The test on API services produced not good results on result data. The JSON data obtained from APIs does not include bookings entity or bookings data. This should show up on a tabular result set that takes into account the number of bookings, the booking entity type information, and the number of persons involved in that booking for that entity type. This should be in conformance with the existing booking API for fetching results. So these set of requirements have been resolved into 3 requirements consisting of feature only. Feature, the first feature is obtain the bookings JSON data for persons. The next feature is include the number of bookings, booking entity type, and number of persons within the booking JSON data. The other feature is conformance of booking JSON data with existing booking API. Now, this is our famous unified process for requirements methodology. It consists of 4 stages: inception stage, elaboration, construction, transition. As an example, these stages are cascaded with each other. Let's say the development stage. Development stage does not mandatorily include only construction phase because it's not a waterfall model we follow, it's an agile process we follow though. So what can include is an inception stage within development, an elaboration stage, which is requirements elicitation stage, a construction phase, which is data development, the construction stage, which is data development, can happen, and transition stage where, for example, the Prince2 methodology has different stages and stage boundaries from where transitions can happen, as well as the sprint. Sprint itself is a transition stage, the sprint, the end of the sprint. Now, a backup repository storing all the details of the requirements is essential for the long run. When a project is handed over, the feature-driven development requirements help the person to retrieve the historical requirement which is used for knowledge transfer. So if you have the cluster of requirements and if they are if they are learned using a deep learning algorithm, and if they are resolved automatically by the deep learning algorithm, then those results are used for handover and audits. A cluster of requirements transformed to useful formats such as a Gantt chart is contained within a requirements dataset. The clusters enable the project members to have visibility of project execution stages. The quality gateway for the backup repository ensures there would not be any requirements creep during the construction and transition phases. One suggestion is during the brainstorm stage, every project member completes their requirements report and then they are validated by a deep learning algorithm to draw up a Gantt chart based on requirements resolution that cascades based on time of delivery. The requirement software backs up all the refined requirements as well. The refinery goes by this. The backed up requirements are drawn on a map with vision at the center, theme, concept, and requirement definition at the leaf. The same structure is seen in the stakeholder maps. Such a structure ensures there is coverage of requirements over all 4 domains, such that when the project members finish their work of entering the requirements into the pool, they would understand how much of the resolved requirements are complete, thereby helping them to make early decisions on priority order of discussion in the sprint planning, as well as what to work and what not to work. Creep is wear and tear of the requirements that happens in the specification. With Agile Requirements Refinery, you can manage creep. With an AI and ML tool referencing the dataset, you can resolve the requirements into individual pieces of features that are deliverable within 2 weeks of time. Such resolved requirements are traceable as well. With Agile Requirements Refinery, requirements are auto-tagged using keywords, which enable the project staff to search the requirements based on the set. It thereby enables the product manager to manage sprint and product backlog effectively. This is a go, no-go decision maker. As you can see on the right-hand side is the product specification that goes through the whole, but it does not get into. The product specifications do not match, and hence it's been rejected. Here this is a go decision maker. The product specification match here, the quality clear, it is quality cleared and appropriate for end user to pick up. Here is an example of a quality gateway. Company X produces A amount of goods in a day. Upon the agreed amount of goods produced in a day, 2% of products are rejected. Rejected ones are thrown away for recycling. The ones which pass through the gateway are either bought or sold. There are several factors that decide what goes through that gateway. For product-based implementations, it is quality assurance, so QA. For project-based implementations, we write fit criterion for every requirement. Now, the quality gateway can be written for 4 different processes. One is the fit criterion, in which we write a single line of requirement for the single line of we write a single line of fit criterion for the single line of requirement, considering its capability to measure the requirements and metrically analyze the requirement into a metric unit. Then the traceability is from child to parent or parent to child, as well as the requirements are traceable at any time when it is being recorded into the system. Third is refinery. Refinery exposes some metrics for detailing the requirements. And refinery is from vision, theme, concept, and requirement definition. Deployment is a stage where you can filter through the requirements, you can validate the requirements, you can bypass or block the go, no-go stage. These are use case and use case extensions. As you can see, there's a branch A and branch B. In branch A leads to an extension use case. Branch B as well leads to an extension use case. Branch A says is an OCL. OCL is an A expression which has been written to obtain that collection. So branch A says collection is bought and collection is a gateway. Branch B says collection is recycled and collection is not gateway. So use cases have extension use cases. They use fixtures of data to conduct tests and preconditions and post-conditions. Use case and OCLs are required for writing down a functional specification. In OCL, preconditions and post-conditions are written to validate an OCL operation. Each precondition and post-condition must be satisfied within the OCL. OCLs can be written in any programming language which takes in input data and produces a Boolean state of every line of requirement. Here are OCL types. Pre-coded constraints in the form of logic and instruction to validate a use case. Basic OCL types are Boolean, integer, real, and string. Operations of OCL types are AND, OR, plus, minus, divide, XOR, ABS, floor, to upper, and concat. Here are OCL collections and iterators. Collections are set, bag, and sequence. Iterators are collection size, define size, collection sum, collection color, collection select. Here are OCL operators. Operators are OCL is type or checks whether that is that type exactly. OCL is new, check whether the OCL is that kind. Validation for Quality Gateway. Quality Gateway involves validation of repository metadata such as package information. The familiar tool integrated with Git is the dependency bot, which is the job of lead technical person to update the package details in the dependency bot. Next is the estimated story points. With Agile Requirements Refinery, we make sure all the story points are estimated before the sprint starts. That too alongside the pool of requirements. Such representation of requirements like in a pool must be separated into a separate model. Validation is an important step for ongoing sprint backlog or product preceding or succeeding product backlog. In the cases where quality needs to be maintained for requirements coming into the product or sprint backlog, and for those going to the project backup repository, the product manager enters logic to sustain the quality gateway. Many organizations follow Excel spreadsheet, and single way to model them is by using project standards. Intricate requirements are modeled using project information model, such as in building information modeling or BIM. A BIM model for software would be a useful technique that makes use of NLP-based automation. Now here are the steps by which the criteria has been measured for requirements, for Agile Requirements Refinery as well as Quality Gateway. So it asks for how much the refinery should be performed. It checks whether the all fit criteria are passed or not. It verifies whether how much the traceability should be done for the requirements. Now these are aggregated from Dharma quality standards. So imagine you have the same cluster set of requirements. You transform the cluster set of requirements using a deep learning algorithm into a master record set of requirements, which is clean and filtered using quality gateway criteria. You send them to create the golden record set of requirements, which are finally used. The requirements dataset will consist of feature-driven development requirements, which is used to resolve the requirements into the sub-hierarchy. The golden set is obtained based on what to deploy finally. Now here is an abstract syntax tree for requirements. The abstract syntax tree is used to parse the requirements text. The requirements text contain word taxonomies which form a tree structure based on requirements refinery. For example, vision, theme, concept, and requirement definition. The requirements are tagged using these categories. On the right-hand side, you can see vision, theme, concept, requirement definition in a hierarchy. And some product manager goes into the form and searches the requirements based on keywords. He tries to change the product backlog, then these set of requirements are getting affected. And in an ARR model, which is a map of these four stages, these four categories, sub-requirements can be easily filtered using an abstract syntax tree. Now, requirements prototyping ensures the intended product is conveyed. To convey about the intended product, it is best to share prototypes. Prototyping comes in a variety of methods. Two main classes involved are low fidelity and high fidelity prototypes. Low fidelity versus high fidelity prototypes. Online seminars or workshops or face-to-face interviews are some of the effective methods to perform requirements gathering processes. Prototypes capture essential requirements and convey the intended product in order to obtain the feedback. Low fidelity and high fidelity. Low fidelity consists of paper-based prototypes. High fidelity is user interface-based prototypes. Low fidelity are non-functional prototypes. high fidelity functional prototypes, low fidelity prototypes seen on screens or on boards. High fidelity prototypes are convertible prototypes that can be converted to the live version. So what are metrics in project backup repository? Project backup repository metrics use the collected satisfaction and dissatisfaction rating about the requirement. The satisfaction rating is a floating point rating. It has pros and cons. It has a refinery coefficient. The satisfaction rating is displayed during the deployment status when the deployment has been happened, and the dissatisfaction is displayed on the gateway status. Imagine your product is a go no go decision maker product, and dissatisfaction rating is displayed on the gateway status to explain it better. The metrics consist of efficiency obtained from a DEA model or a data envelopment analysis model. The metrics such as relevance are obtained from data decision management units as well as the Gini impurity. The importance is measured from SHAP or Shapley additive explanations. Shown here are clusters of requirements. Decision on the right hand side, it is decision management units, and on the bottom it is importance hierarchy tree. The clusters of requirements are formed in the initial stage after collecting the requirements from project team. The decision management units are figured out from the story points and entered sequentially in the same order, which maintains a priority order of the requirements at planning. The tree structure shown here is actually an abstract syntax tree that includes architecture such as word-to-vec and word taxonomies. So imagine there's a requirements text and you need to parse the requirements text. You use an abstract syntax tree to organize the requirements, and it is using the word-to-vec indexes and word taxonomies. So that's it about the presentation. I suggest requirements creep is a major issue, and how to solve is to develop a mathematical model to include Gantt charts during every discussion, to make the Gantt chart as a publicly available Gantt chart, and to enable the requirements to be a free flow document coming from the stakeholders and the project staff. So this sort of a solution is especially useful to work in a remote-based environment where people are working in different countries as well as within countries. So it's quite difficult for them to collaborate online. And such a creep management system or a project backup repository which saves a repository or history of requirements is essential. Thank you.